Hello everyone, my name is Zehra and today I'm going to present you my final year project where I studied and created a customer support agent for the e-commerce industry. To start with, we have our project overview. So this project focuses on developing an AI-driven customer support agent to enhance the efficiency of handling user queries. And the goal is to reduce response times, improve customer satisfaction, and automate frequently asked questions handling through intelligent and data-driven interactions. Before going any further, we need to understand what are the AI agents. So an AI agent is a system that perceives its environment, makes decisions, and takes action to achieve specific goals. Those agents can be simple or highly advanced. And in the context of our project, our AI agent is going to perceive user input in natural language and process that input using semantic understanding, here we use sentence transformers, and is going to act by returning the most relevant response from its knowledge base. And our dataset is Vitex Customer Support Large Language Model Chatbot Training Dataset from Hugging Face. It has over 27,000 real-life customer queries, and it's labeled with flags, interaction, category, and response. We chose this dataset because it supports applications in semantic search, Q&A systems, and chatbot training. Here we have a representation of our dataset, which has flags, interactions, those are the questions of the users, and category, intent, and response. Response is the answer that our AI agent will give us. We use sentence transformers for this project. So sentence transformers are models that convert entire sentences into high-dimensional numerical vectors. These vectors preserve semantic meaning, allowing the system to compare sentence similarity. And for our project, we use all-mini large language model from Hugging Face for its speed and high accuracy in identifying similar sentences across languages. Here is the simplest form of a sentence transformer. It passes a sentence through breadth to produce word vectors and aggregate these word vectors into a single sentence vector by mean pooling. Then we used cosine similarity to find out the similarity between the questions and the answers. And cosine similarity is a metric used to measure how similar two vectors are based on the angle between them. A similarity score close to 1 means the vectors are nearly identical. In this case, the sentences, the questions, and the answers. And a score close to 0 indicates low similarity. And here it shows how cosine similarity works between two sentences and how our system works. So the user types a question, for example, how can I cancel my order? And our system is going to encode and do the similarity matching and will give us the top match. Here we have cosine similarity distribution of the user input. For example, canceling order, we have different types of typing, and this is the distribution of our cosine similarity. And this is the distribution of cosine similarity when the user types an irrelevant question. This gives us the cosine similarity of those irrelevant questions. And here we have a preview of our agent. Let's see. So when customer says, how can I cancel my order? Our agent is going to give the user an answer. It's quite good. And it can also deal with typos, writing mistakes. It will give another answer, which is quite near to the question. The customer can also ask another question like, I want to delete my account. Our agent will give a reasonable answer to this question as well. And what if the customer asks questions, irrelevant questions? Our agent will try to give the most relevant answer, but it's still not quite good. And for example, customer can ask, how are you today? And this is going to be the answer of our agent. And the impact and the conclusion of our project is faster response times and increased customer satisfaction, reduced workload on human support agents, and a foundation for scalable intelligent support system. And this is a step toward building an AI agent that not only understand human language but also evolve with the user needs. And feature improvements can be sentiment detection, so that the agent can personalize responses based on the emotional context, and multiple response suggestions, because for very vague queries, offering a list of potential answers can be good. Topic classification and real-time API deployment. And finally, I would like to express my sincere gratitude to everyone who supported me throughout the development of this project. My supervisor, Ilhami Morak, for his invaluable guidance, encouragement, and insightful feedback during every stage of the work. And special thanks to everyone who contributed to open source tools and data sets. This project would not have been possible without their work. Thank you for your time and attention.